So thank you very much, and welcome everyone on the call to the Flame webinar for the third open call. During this call, our purpose is to share with you information about the Flame project, also our expectations for the call and the process for applying. You'll also be given the opportunity to ask any questions towards the end of the call itself. There will be a number of presentations covering different aspects of the project. During this first presentation, I'll give you an overview of Flame and the expectations of the call, and then there'll be further presentations going into more detail about the technology, the different replicators available for the targets of experiments, and also a presentation on the process. So I'm going to kick things off, and first of all, welcome and thank you for your interest in the Flame project. The Flame project itself has been running for a number of years now. This is the third open call, and our goal is to establish, through the process of experimentation, a new platform for delivery of services in 5G networks. The focus of our applications in this context is interactive media systems, and we're specifically exploring the type of integration between the services themselves and the underlying communications infrastructure, the software communications infrastructure, including bringing together compute storage and software-defined networking. The activities in the project are conducted through experimentation, and these experiments explore different aspects of acceptance, viability, and performance. There's a DevOps process which each experiment goes through that is used to explore each of these aspects and increasingly move towards more operational environments, ending up in trials conducted within sites around Europe, such as Bristol, Barcelona, London now, and also in Sicily.
So I was just talking about the beginning of the project, and this was the slide I was supposed to be saying. And essentially, we're looking to work with third parties to help understand the benefits of the Flame platform. These third parties are developing new types of media services and looking to see how and explore how the services can be optimally delivered over new types of 5G service delivery. The people involved in the project are, we're an H2020 project, an R&D project. We currently have 4 European locations. Initially, we started with Bristol and Barcelona, and in the last open call 2, we extended to replicate in London, but also in Sicily. There's 11 consortium partners. There's 20 plus third-party experiments, looking at different types of media, different types of service delivery in these locations. And there are 2 replicators, the London and Sicily examples. The Open Call 3 is part of an overall budget of 2.2 million euros, which we're using to increase the impact of the project. And we hope that we'll receive some exciting applications from you. In terms of the delivery phases, the project is in 3 phases. So we're today at month 33. We're 42 months in duration. Project is due to end June 2020, and we've been running experiments for some time, and therefore we believe we've reached an increasing level of maturity that allows us to explore some very exciting challenges. What we offer, so first of all, is that we offer a series of infrastructures which we call replicators that are deployed in different cities. This slide actually only has the 2, Bristol and Barcelona, but there are additional, you'll hear from Sebastian later, about London and Sicily. And what this is an experimental network deployed within a real context, real site, that includes a hierarchical computing infrastructure including edge, metro, and centralized data centers at different scale, all connected by a software-defined network. The key is that the infrastructure is deployed within an urban setting, and that offers context for experimentation, as it allows you to think about experiences for the populations and communities which are enjoying the place in which the infrastructure is deployed. So this link between the low-level infrastructure deployment, the management of that infrastructure through the Flame platform, the new types of services and the experience they deliver is what Flame experimentation is about. We offer a media service delivery platform that has some distinct properties. The properties are defined here in the center of this slide. Specifically, we offer flexible service routing, and this allows us to quickly deploy services and connect services anywhere within the network. We have ability to place services within the network through the concept of surrogate service management. We have cross-layer management, which brings together monitoring and analytics, so we can understand the usage and performance of services deployed in the network and create links or correlations between the performance of the infrastructure and the necessary performance of the services required to deliver a qualitative experience. Finally, we have a set of default media services, which we call foundation media services. These are exemplars of streaming and storage, transcoding and transrating, which are common within many applications. These aren't essential, but they are useful as primitives when building an overall application. A key part of Flame is the outcome from experimentation. So what we're looking for is experiments that clearly define a design that aims to make some sort of performance improvement or some sort of benefit to users of the system. To do that, we need clearly articulated experiment objectives or test objectives, if you want to think about this in more of a development paradigm, that define things that we want to measure, why we're measuring them, and the difference that is made by using the Flame platform. There's a fairly overarching monitoring framework that allows you to capture different types of metrics, but we want to emphasize the fact that when designing an experiment and making a proposal for this open call, that we need to see the quantifiable benefits through the experiments. So making it clear in the proposal what difference you expect to achieve through using Flame and your services, that would be very beneficial. Flame offers a set of methodologies that supports the design, implementation, and execution of the experiment. The experiments can be quite complex. As you see, we're covering the full stack from infrastructure right up to applications. This is what we understand as the systems under test. And your experiment could be to see whether we have what difference is made to quality of service and quality of experience. Could be to understand resourcing policies and associated costs, or even begin to explore relationships between different stakeholders which are impacted by your service in terms of service level agreements. These are all possible targets for the outcomes of the quantifiable benefits of the experiment. Now, throughout the process of experimentation, you'll be assigned a mentor, and that mentor's responsibility is to help you in the design and also understand the potential and the constraints of using the Flame infrastructures and platforms. And that teamwork is the key aspects of a successful experiment. So I want to emphasize that we are all learning as part of this. This isn't a case where you're just coming to use our platform. The purpose of the open calls is for everybody within the experiment team to firstly understand what the service is trying to achieve, and B, understand how the platform can make that better. And for that to happen, we have to team together quite closely. And then we offer what we call market showrooms. So and this is all about the benefits that you will get through engagement in Flame. So by running experiments within our replicator sites, this is an opportunity to market your solutions or your ideas. The trials themselves can include user participation. That participation creates interest and has a significant marketing potential. And we've seen that throughout the project itself that many of the experimenters have benefited by running experiments and building media material and promoting that as part of the work that they've done. So this is an overview of the various aspects of the Flame project as just discussed. And if you sort of pull it apart, you will have noted that we have an overarching concept picture which brings the offering together. Your experiments, if you look at the top of this picture, are primarily where we're focused. The rest of it is provided by the project itself, and that's our job essentially to deploy the infrastructure and offer the platform to you. So that's an introduction to the Flame project. Let's have a quick look at the scope of this call. So as discussed, we are focused on media services. So primarily this is about content-rich applications across the creative industries. As such, the human is a key aspect of any proposition. So user experience, enhancing user experience, and human-centric interaction is key. The type of content that typically is associated with that includes augmented reality and virtual reality, 360-degree video, to some degree ordinary typical video and audio, and bringing that together to understand how the audio can be adapted and personalized, how it can be made more interactive and responsive, how that content can be localized, so for use within localized communities and within the replication sites, and how the content can be distributed and placed within the network depending on the movement of individuals and populations. A key aspect for the third open call is the service design patterns. The service design patterns are primitives which are used to understand the decomposition of an application. Now, up until this point, what most developers are familiar with is the mobile cloud paradigm, where an application is deployed on a mobile phone and supported by services deployed within a central, typically public cloud. With Flame, the computing infrastructure is now distributed throughout the city and has different scales and includes edge computing. This has impacts on the way in which services inside an application are decomposed into components and how they are scaled not only within the cloud but also scaled geographically based on the demand for those services from communities within different locations. As such, we've defined a set of service design patterns which are available and documented as part of this open call. Here we list a few things like opportunistic multicast, nearest playout, proxy playout. All of these have distinct functions and benefits to applications and allow you to design applications that make the best use of the Flame platform. We would expect experiments to use our design patterns, and we expect them to propose that as such. And these patterns are the way in which we would quantifiably measure usage performance and cost, because we can see that by using these patterns, they have distinct advantages in terms of reduction in network usage or reduction in latency, and the relative increase in experience as a consequence of that. More specifically, we are looking for three types of experiments. The first two types are on this slide, and this is about localized video production, consumption, and delivery. We've had these in previous calls. These are about understanding how to better distribute video content within a very localized setting. We're using the computing infrastructure deployed within the edge. The second is about using augmented and mixed reality content. So this is about future experiences. You may even consider new types of devices that are emerging and how we can better deliver content to those devices. That's very much of interest for us in this open call. And the final experiment that we're looking for is that the nature of the Flame platform allows us to dynamically extend infrastructure slices. So what we're looking at is potentially an industry partner coming in who has some localized capability they can bring. Maybe this is a scenario with a TV company where they can attach some capacity to the existing infrastructure. That can be done quite simply using the Flame platform and the way in which tenant infrastructures are configured through infrastructure slices. And so we're looking for models of extension of the local infrastructure, how that infrastructure can be managed through policies, and also how that infrastructure can be used for new types of experiments building on top of that. So, you know, there's significant resource available for a partner willing to come and explore that scenario with us. So that's a high-level summary of the Flame open call. Obviously, there's more information that we're going to present now. There's also information on the website, and when we get to the end, you'll be able to ask questions, and there's also an email address which you'll also be able to find out more information as you develop your proposals. So that concludes the first presentation. I'd now like to hand over to Sebastian from InterDigital, who will provide more detail about the Flame platform and its capabilities from a technical point of view.
Great, thanks you, Michael. I do assume you can see now my slides?
Yes.
Great. So I want to briefly talk about the platform itself and the foundational meter services we are offering, and give a bit of insights in what the platform essentially offers to you as the experimenter, and a bit of reasoning why we are a bit different to what you can find on the current internet, and what you should keep in mind once you apply for the open call. So, right. So the Flame platform essentially is a set of components which are truly modular and fully orchestratable in an MFB environment, in our case, an OpenStack. And the quite modular and layered architecture we have, which includes also the cross-layer optimization, analytics, and control, allows us to offer a platform that performs routing for service on top, and also offers a very rich set of monitoring that comes straight from the deployed service and is available to the experimenter through through APIs and web interface for further investigation. The main key of the Flame platform, as Michael already introduced, is that we want to bring a service function, or the service you essentially develop, straight down to the edge of the network, in order to see certain benefits over current cloud deployments, to essentially challenge the cloud paradigm. As I said, the infrastructure provides OpenStack and OpenFlow, so it's a fully SDN OpenStack-based infrastructure, and the platform requires a fully programmable infrastructure, and the deployment itself is a matter of minutes, and the platform is literally ready after this short amount of time. And what essentially get out of this with the advanced routing we offer is a much better quality of experience for the end user. So in terms of technical proposition, so there's two aspects to that. There's first the fast and adaptive angle, which is for all HTTP-based services, we can offer the routing of HTTP-based traffic to the nearest point of presence. What we mean by this is essentially your service must be decomposed into individual service functions, and they can then be deployed across the platform, either in the data center, somewhere in the middle, or further down at the very part of the very end of the network at the edge, which essentially gives you the one hop away methodology where you can experience a much lower latency, and ideally you want to have also the highest possible throughput instead of going always back to the data center or even to the cloud. So instead of scaling vertically, instead of staying vertically, what you do in the cloud, where you literally spin up more containers in a single compute environment, in Flame, we allow you to horizontally scale, where you take a service and bring it down much closer to the user, so that you essentially have less users per service endpoint, which is a different way of scaling the load across service functions. With this, what we offer then is a improved service request routing. So while you change where your service is being provisioned to the end user, you can do this switch within a matter of milliseconds, because the platform does not rely anymore on DNS and using DNS to resolve your service to an IP address in order to understand where you should bind your HTTP session to. Now, while this is certainly possible, those solutions with triangular routing and current cloud solutions, they do not have the same scalability in terms of how fast you can reroute traffic, and the triangular routing that comes with that is fully mitigated in the Flame platform because it does not use DNS anymore. As described by Michael, as part of the design patterns, one of the key technical propositions is also the delivery of HTTP responses using opportunistic multicast. What we mean by this is that for any request you're sending, the response can be sent out in a multicast fashion through the network by the platform. So if you imagine if you have something like YouTube or Netflix where you play out a video and there's more than one user that happens to watch the same thing at roughly the same time, the response for each user, if they watch the same thing at roughly the same time, is sent out once through the network, and only at the very edge of the network we would replicate it back to the IP world, which essentially reintroduces multicast for HTTP. On the other side, we also offer a very robust and secure platform. So the very first thing is the ability to have the platform figure out which service you have deployed actually offers the resource for HTTP you're looking for. That's what we call network level indirection. So essentially, if you send off a request and the first service function that happens to be right next to you at the edge does not have the service, we just go, or the platform goes through all deployed services that offer as resource on the same FQDN. We just find the one that actually has the resource and would choose this one as the anchor point to establish the service. The other benefit the Flame platform provides is we actually move away from things like the insecure object references, what you have, for example, on Facebook, while you're having accounts where you have to log into a platform in order to receive content. The content itself, they are deployed in CDNs, and if you have the link to this particular content, there's no link back anymore to the accounts, so you can easily access the content without being authenticated at all. In Flame, that's not the case, because the service you deploy, including the content, is fully owned by the experimenter, by the service provider on top, and for all users accessing a particular service, the rights can be fully prevailed by the service provider. Which brings me to the last benefit, which is the secure end-to-end access to content. So while we do support HTTPS, the only thing in order to be able to have all the key benefits on the left, you would need to share your certificate with the platform, but only so that we can peek into a header in order to do the service-based routing. Now everything else stays secure. No content needs to be decrypted in order to have all the benefits. So the rights and the and the secure content that a service provider demands, for example, like Netflix, which would never allow you to look into the content and play around with the content itself, would be would be not given to the platform, and all certificate sharing is literally only for looking into the header of HTTP. Now, what changes a bit in terms of how people think about service nowadays, and Michael introduced this already. We want to move away from this typical cloud paradigm where you have a client, an app usually, and a cloud solution or a cloud deployment where your service runs. And then you use your ISP, internet connectivity, to communicate with the server instance. And that's a very proven model on the internet at the moment for services such like Gmail, Facebook, and Twitter, where each service request by your phone and by your app essentially results in a little container that gets spun up on the cloud and serves you as the user. And that's where a more service-based view would mean that in order to have only the cloud that serves you, want to bring the service now closer to the user in order to improve a quality of experience, which essentially also means that you need to serve less users with the same type of instance. And this is what 5G wants to bring to the table with all the integration of verticals. Now, the vision is certainly that we want to move even further to have that the edge can be literally everything. So while you actually have then something what we call anything as a service, and your service essentially can be deployed and run anywhere, we actually move towards a world where you as a service provider, or as the experimenter, you have the full choice of where which service endpoint would run in order to serve the user, and the Flame platform then offers you the monitoring in order to determine where's the best place to execute a service. So how do we do this? So the dialogue which an experimenter has with the platform is essentially you have a media component like your web service run nginx or Tomcat application, and this one is then given as a resource template to an orchestrator. So you package it up yourself and you give this package to us, and you talk to the orchestrator saying, look, here's the resource I want to deploy at this particular type of, on this particular edge there. What you also do, you define a demand supply model where you say under certain conditions, you should change my resource to that in order to meet the KPIs, for example, throughput or latency. And this is then translated back towards the orchestrator of the platform so that once a certain KPI is not met anymore, certain triggers are issued, and then the service is changed inside the platform in order to meet the KPIs again without any interruption or any communication from the media provider anymore. Now, how we do this internally? Well, we do know as the Flame platform how the infrastructure looks like. So we know what constraints we have in terms of topology, in terms of resources, network resources, cloud resources. And the orchestrator which has received the resource template by the experimenter can then make the decision of where to place what, which is part of the template, but also the management of the placement and receiving triggers through KPI measurement is all then done through the service function endpoint management and control, which essentially is a set of policy identifiers where you define this latency is not bad anymore with this value, please do that for me then. And this then goes into the service function routing. So the routing then makes sure that if you change the execution point, so if you move, for example, your video playout point much closer to the user, the service function routing receives the instructions to serve this new playout point, which based on shortest path, then, for example, would then bring the user to the next hop or to the instance where you deployed your service instead of going back to the data center. And the service function routing, as I said, receives the trigger in order to do this, but also then goes back to the infrastructure and configures the the resources required in the infrastructure. This brings me then to the foundation meter services the Flame project offers to the experimenters. So essentially, what we have experienced is that a lot of experimenters require the same, or roughly the same, media components in order to describe or to deliver their service. So the Flame project offers pre-coded meter foundation meter services, and those foundation meter services have been implemented in a way that they immediately take advantage of the platform capabilities such as the coincidental multicast, network level interaction, or the chaining possibility. So all those foundation meter services are HTTP based, and they can be literally taken by experimenters, and they can straight start off with the assumption I have, for example, a video on demand service where I can place content from a storage engine, and I can just link a user to this service chain. And once I'm deploying this, the foundation meter services have been tested and fully integrated with the service functional routing, so that all the capabilities we have described, they work straight out of the box without you as the experimenters reinventing the wheel by, for example, writing a video on demand service. So what do we offer? We offer a metadata database, which essentially stores information about media content, primarily video traffic. Then we have the video on demand and the live streaming engine using MPEG-. There's a content conditioning, including the transcoding FMS, which allows you to, if you upload, for example, an MPEG-4, you can convert it into an MPEG-, and you can define the rates you want. There's a content ingest and storage in order to store any type of content, a quality analysis component, as well as a virtual CDN, which essentially allows you, instead of having, for example, only one storage, and how you actually update the storage with new content is entirely up to you. The Flame project offers now a CDN implementation where the update is done on the fly for you, and you have control over the lifetime of the content there. And finally, I just want to briefly walk through the 4 sites we have at the moment in Flame, and show you the platform, how it looks like there. So essentially, we have Barcelona, Bristol, King's College London, and a rural area in Sicily. And what you can see across the next 4 slides is essentially the platform, always in the marquee bluish color, and you have the circles or the ellipse that actually have no color. They are the SDN switches, and then the orange boxes are the IP-only endpoints. So for example, here on top you have the internet, which has then a platform service instance. So they are all OpenStack instances that offers you internet access. And then across the entire platform, you have those boxes that say cluster in the end. A cluster is essentially the OpenStack instance, which is then offered to you as the experimenter, into which you can deploy your service. So in Barcelona, we have 4 access points, and if a user connects, for example, to Flame 3, and if you deploy a service on this particular cluster, the Flame platform will route your HTTP traffic automatically to this cluster without you doing anything. So imagine you have the same video container deployed in each cluster here at the edge, and you have at each access point users accessing the same content. They would be all served from individual clusters. So the core network here wouldn't see any traffic. In Bristol, it's slightly bigger, just because there's more access points and the compute facilities are slightly larger than in Barcelona, but the concept is the same. You have a cluster right next to each access point, and you have it's 7 access points in Bristol. And they all, across all platforms, you have a cluster at the data center and you have a cluster at the very edge. So you have essentially a 2-tier edge deployment here. King's College looks more like Bristol again, Barcelona. So they have 1 SDN switch and again 4 access points, which have a cluster attached to it. The good thing is, and I will briefly talk about this later again, that in King's College London, we have 2 types of edge compute nodes. One is a low latency edge compute node with a real-time kernel in order to have potentially resource or real-time service functions on top that require the real-time requirement. And those type of compute nodes could offer a much more predictable execution of your CPU loads. And in Sicily, so the reason why this figure looks slightly different is essentially because we are still configuring the platform there, especially the infrastructure. You have OpenStack only at the offices of the company offering the or that access the replicator, and then you have in 6 locations in the rural area of Sicily, you have physical nodes into which the Flame platform is deployed with clusters each, and all those locations are interconnected over a high capacity backhaul Wi-Fi, which is then linked back to the OpenStack deployment. So there you would see a tremendous difference between running a service locally, for example, at the municipality, compared to the videos deployed at the data center at the level 7 offices, because you would actually run over a longer Wi-Fi link there. Okay, that's all from my side, and I believe I now give to Navid from Bristol.
Thank you, Sebastian. Your belief is correct.
Good.
Hello, can you hear me? Hello?
Yes.
Good morning. Let me share my screen if I can. Yep. Okay. Can you see my screen?
Yes.
Thank you. Good morning. I'm Navid Solju from the HPN lab in the University of Bristol. It's not moving. Is it not moving? Sorry, can I check something? That it seems that. Can I just check that you see the first page or second page here? Because
Still the first one.
Still the first one. I'm sharing the screen. Entire screen. How about that?
So Navid, I had to actually launch the GoToMeeting application to be able to display. Oh,
Yeah.
Yeah, we just saw your next slide, so that was okay.
Good. Okay. So, thank you. So the University of Bristol HPN lab is a research lab, and the objectives and the use cases that we run here generally for various projects are in the region of enhanced mobile broadband and ultra reliable low latency communications, as well as massive machine time communications. The types of technologies that we work in are mainly OSM and software-defined networks, which is heavily used in the Flame platform, as well as NFV and multi-access edge computing. So these 3 concepts are used in Flame, which was previously discussed. But in addition, there are several projects running here on machine learning and artificial intelligence. And most recently, we are quite active in developing tools for network monitoring and analytics. This is a section of the map of Bristol. On the top right, the U icon is the university site where I'm talking now from, the HPN lab. The main site of the Flame platform testing is this area, the Millennium Square, which is highlighted by an S, where the towers and the compute nodes and the access point are installed, as well as recently the M, which is the MSHA museum. And we've got similar facilities there with slightly smaller. In the square, we have got 6 access points, whereas in the MSHA, we have got 2. Also, there are other facilities which are not used in Flame, but it's good for you to know. There are access points in the Bath, which is a city about an hour from here, and also in Watershed, which is sometimes used for other projects. You can also see the D label. This is Slough. This is another city about 2 hours from here, and it's one of the products made by university, which is called the 5G exchange, and that's another story which we will do later. Okay, so this is a logical view of what I just presented. The Smart Internet Lab is where the infrastructure is located. With regards to Flame, the data center and some of the switches are located in the Smart Internet Lab. And from there is fiber connected to the Be the Curious, which is a building at the Millennium Square. And these boxes are the multi-access edge computing towers, compute nodes, which are then fibered to the towers, to the access points, as well as the MSHA, which we just talked about. So before going into further details of the infrastructure, let me run this video which introduces you to the overall activities of the HPN lab at the University of Bristol. So this is the square. Okay, so I've just been told that you can't hear the music here. So this is a square, and we just saw the towers, which you just missed. This video is about a major demonstration of the several projects that we had last year in March. And some of them did touch the concept of MEC. Okay. This is an overall view of the square from the top. You will see that, so on the right-hand side, this building is the We the Curious building, which has a small room where the compute nodes are installed, and there are fiber to 6 towers. See tower 1, 2, 3, 4, 5, 6, where the access points, where the Wi-Fi access points are installed, and each is radiating its own SSID. flame 1, flame 3, 4, 5, 6, and for the time being, flame 2 has been shut down for various reasons. But in addition to each SSID, to individual SSID, the project decided to also radiate a single flame SSID throughout the square. So each tower is radiating a single SSID flame, but in addition, its own unique SSID, SSID 1, 2, 3, 4, 5, 6, etc. And this is a view of the MSHA, which is just on the other side of the river. It's about 300 meters away from the Millennium Square. There are 2 access points installed here. Now, there's a difference of functionality, if you like, between the square and the MSHA. Whereas the MSHA, wherever you stand in the square, sorry, the Millennium Square, wherever you stand in the square, you can see an SSID. In MSHA, there are areas which can go totally blank, or one signal can go quite low, and the other signal is quite strong. And that's where some use cases can be probably more successful in this venue rather than the Millennium Square. This is a logical view of the platform which Sebastian has already explained, so I won't go through it much. Just to reiterate that there are various access points in the Millennium Square, SSIDs 1, 3, 4, 5, 6, and these 2 SSIDs belong to MSHA, and there's a single SSID which covers the whole Millennium Square and MSHA. The S10 switches, and there are 2 S10 switches on edge core hardware. One is in the Millennium Square / with the Curious, and the other one, and the other edge core switch, which is hosting an SDN switch, is in HPN Lab in the university. And this link, as I said, is about 1 kilometer, all fiber. And finally, as I think it has already been explained, but please bear in mind that to come here, you make sure that your application has been tested in Sandbox, Sandpit, etc. And also you have remotely tested and deployed, but we can't say tested, but at least you have deployed your application on the Bristol infrastructure. We have had various people and experimenters who hadn't even tested and deployed their application on this infrastructure, and they came here for 2-3 days. They spent 1 day, 2 days just deploying, whereas they could have easily done it from home. And to access our infrastructure, you can just send me your email address, and I'll send you a username password to access the front end of the Flame platform, where you can deploy your application.
Thank you, Naveed. So we now move on to the second infrastructure. August Betzler from Barcelona, who represents ITCAT, and this is one data there.
Hi, everybody. Can you hear me?
Loud and clear.
Okay, perfect. So yeah, thanks for the introduction, Michael. I'm August Betzler. I'm working at ITCAT, which is a research center located in Barcelona, and I'm here with Mariano from the city, Mariano Lamarca, sorry, from the City Council. We would like to give you, similar to the overview that we just gave from Bristol, we're going to present you Barcelona. Well, first of all, what we have here in Barcelona is a replication. Basically, we have several points of in the hierarchy of the architecture, which are mapped to main VC, which is our main compute environment where we have heavy servers, and the edge compute zone, which is on the street. These are interconnected over fiber, and here at the street level, we have the access nodes, which are basically Wi-Fi nodes, similar to the ones that are deployed on the Millennium Square in Bristol. Basically what this infrastructure does is it hosts the Flame platform, and for the experimenters that are interested in coming to Barcelona, we offer, as I said, compute resources that can be used either being at the main DC, which are maybe for offloading heavy functions, or at the edge when you need low latency and close to the user compute capacity. Here a map of Barcelona. So as you can see, there are basically two main sides. The i2CAT side, which is here in almost outside of the city. Here we host our heavy compute equipment, and we have a dedicated fiber with 10 gigabits per second connectivity up to the so-called 22@ area, which is an area for experimentation where we have deployed our street infrastructure. Here we have the city council building, which hosts some networking equipment connected to finally the street deployment, which are the lampposts plus a cabinet server, which can be used for your experiments. Here you can see a zoom in on the area, the on-street area where experiments can happen. So basically, we have a chain of lampposts where we have. Sorry, I have someone. I hear some noises. I don't know. Someone has not muted the microphone. So we have these 4 lampposts along with a cabinet where the compute server is hosted. And what we can offer you is basically a radio access connectivity along the street with around 300 to 400 meters of range, and where you could deploy either on using all lampposts or just a subset of the lampposts for your experiments. So this is what it looks like in real life. So we have these lampposts. We have the cabinet, which is hosting the networking and compute hardware. And this is a very quiet area, so there are not a lot of pedestrians for experimentation. It's quite nice. You have a lot of space to walk around and do your experiments. Here, a brief overview of the compute nodes. I think the important numbers are here on the bottom. So, of course, the Flame platform has some requirements on the compute usage. So what at the end is left for you experimenters would be these numbers. So your applications and your services that you deploy can use up to this amount of resources. I have to say though that, for example, here at the edge, these virtual CPUs and RAM are split among different clusters, as Sebastian has introduced them before. So these are the generic numbers that you can assume that you will have if you do some experiments in Barcelona. On a bit of information on the wireless equipment, we have build our custom nodes. Basically for you, what is interesting is that we are using 802.11 AC. That means you with 2x2 MIMO, you can reach quite nice throughput with that. We assume, even though we didn't have a use case where we had many users, we can assume that we can host up to 8 users per lamppost, more or less. So if you use all lampposts, theoretically your experiment could have like around 30 users or so. What is also shown here is a wireless backhaul, which currently is under inspection because we had some issues. But theoretically, if if things turn out fine at the end, maybe you could have the chance to experiment with wireless backhaul. For now, though, experiments that are designed for Barcelona have to consider that they will have only radio access network. Similarly to what has been done in Bristol, we are here flexible. We can offer you using one single SSID that is shared among all lampposts, or different SSIDs, whatever suits your experiment design better. Okay, so finally, a bit more information. I won't go into details, but so as I think it will be introduced maybe later, we're using different channels for communications. Just a message from our side. We as Barcelona are more than happy to give you support with your experiments, especially everything that is related to questions to infrastructure. And our team is always replying to emails. We have different ways of communicating that, if you would then be participating in the project, are listed here. And other things is once you have done your experiments in the emulated environments that Flame is offering, you could come to Barcelona, do some initial experiments, do test after everything is working, and finally do the trials where you actually showcase your use case. Yeah, we have some testbed access policies, well, basically some times during which we operate the network, and some limitations, like, for example, we're not hosting experiments on holidays, but I think this is, yeah, well, I mean, it makes sense. We always want to provide the best support, and for that we need availability. Yeah, one maybe important point is that the hardware is the one there is now. There is no plans of for you to be able to add another hardware. Like if you want additional compute node, that's not possible. However, I think with what we have now, there is quite a lot of things you can do. And well, one last point, but I think this is also more relevant to the point where you already got into the project. Like we like to plan things ahead. So if you do use the Barcelona infrastructure, yeah, just be aware that we have some timings regarding preparation of the experiments. In best case, like 3 weeks before you want to do experiments, let us know. We will plan together what needs to be done. Yeah, basically that's it. We're more than happy to answer any questions, but I guess we will do that by the end of the call, right?
Yep, thanks, August. So that's Barcelona. Now I'll hand back to Sebastian, who's going to briefly give an overview of London and Sicily, who couldn't attend the call today.
Thanks, Michael. Just to also briefly state this here. So King's College London and Level 7, the two OpenCall 2 winners, they are mentored by me, and that's why I'm presenting their slides. So I've been working with them extensively over the last couple of months to get their infrastructure ready in order to get the Flame platform deployed there. So the slides are a bit shorter. They don't go too much into the infrastructure layer. Just essentially to give you the bits and pieces you would need to know in order to understand which of the replication sites are the one you would like to apply. So for KCL, essentially KCL is a data center type of private cloud deployment where you have 7 compute nodes and 1 controller, so quite a number of cloud resources available. You can see 88 virtual cores, 1 terabyte RAM, 7 terabyte of disk if you combine all of them, but because they are physically constrained into one single location, we had to make a bit more sense out of the topology, how it should look like there. But you will have something, as you saw in the in my slides before, that the logic topology does look like Barcelona a bit. So you have there 1 SDN switch. So we have the choice there of running over 2 type of SDN switches, which is important for us as a Flame project to verify that our deployment works on more than 1 or 2 SDN switches. And as I stated, there's 2 compute nodes where the real-time kernel is configured so that the essentially we can do, or we can test that the Flame platform could even run more performant than on other compute nodes, which, for example, if there's a VR demo or VR experiment planned, we should see certain benefits from running on the real-time kernels there, just because we can essentially push higher throughput and lower latencies, what we obtain then from the configuration through those particular compute nodes. The environment there is essentially one single floor at King's College indoor deployment. There's 4 Wi-Fi access points. It's essentially a round of offices in a circle. So you can always just see 1 or 2 access points based on which part of the circle you are at this particular department of King's College. They do have, as Navid stated, in Slough, there's the 5G exchange point, which interconnects KCL with Bristol, because they were both part of the 5G OK efforts. So if there's a need, we could also hook up the 2 deployments to form a single deployment so that the service could run in 2 cities, all orchestrated through a single platform. But that's something that's possible, but not on the agenda at the moment. But again, it's possible. So the topology for KCL, so 4 access points on the single floor indoor. You can see those 2 low latency compute nodes into which you have a cluster deployed, which is provisioned to experimenters, and then 2 more compute nodes with a standard configuration, which then serves the other 2 access points. Given that the 88 cores are for the entire platform, plus the servers on top, each cluster here, the edge, like in Barcelona, will give you around 4 cores roughly that are given to you as the experimenter in order to deploy your service, and they are exclusively allocated to you then. That's about KCL. And so the last one is about Sicily. So Level 7 is the company that has won an OpenCall 2, the replicator, the second replicator slot. So the deployment there is a hybrid deployment, which is quite different to all the other 3 sites. So while they have OpenStack in their data center, which gives 32 cores, 144 GB of RAM, and 8 TB of disk, the nodes out there in the rural area, they're all hardware-based, and the Flame platform there is deployed by hand, not through OpenStack. No difference to you as the experimenter, but as I've said, those sites are interconnected over long-haul Wi-Fi, and this essentially means that's the map of the city Busseto, that each pin here is one site. Each site will have a machine that gives you around 3-4 cores in the cluster, so that you can deploy your services there. But because they're all interconnected over Wi-Fi, you really want to front load anything that is resource intense, networking resource intense, like throughput, playing out videos, not even talking about VR. So this type of deployment is really quite different. And also in terms of use cases, this should really open up the floor for use cases that demand users that are more or less desperate for services that simply wouldn't run without Flame, because the internet connection is just not stable enough and strong enough to hold up, any type of video playout for 1,000 people. The Flame platform saw this topology before, so they're all connected over the water silo location and an SDN switch at a cemetery. Sounds a bit black humor, but that's certainly the case. So the cemetery that has an SDN switch and a wireless backhaul to all the 6 sites where, again, a physical node is deployed with clusters, so that you can deploy your service there. The area here is essentially the city center of the little city in Sicily. They have a public square. They have an indoor deployment at the municipality. Then there's an indoor library, an indoor school, and a cultural center deployment. And as I've said, each site will be interconnected over Wi-Fi with at the moment, because 802.11n they can offer, it will not go beyond the 300 Mbit per second throughput. So supporting, more than 10, 20 users per location, all accessing the internet will not work, because they're all sharing in the end one single backhaul link back to the offices of level 7. And that's about the 2 replicators.
Thank you, Sebastian. Thank you, August. So the final presentation this morning is regarding the OpenCall process. I'd like to hand over to Lamprini, who will provide that information.
Thank you very much, Michael. I hope that you all see my my presentation here. So I will give you some main information about the process of the OpenCall. Everything, of course, is the information document on the website, but it's this will give you also the opportunity to make some questions if you have any doubts about the details. So in this third OpenCall in the Flame project, we are going to fund 13 new third-party projects in 3 categories: the industry trials, SME trials, and startup trials. In the table here, you can see also the limits for the funding and the total cost for each one of the projects. So we will have 2 industry trials, 5 SME trials, and 6 in the category of startup trials based on the city that each one of these are submitted, and the ranking as well. And I'll give you some more details later on. So these are the main rules that run the OpenCall. These are the similar ones that exist also in the information document, but the most important of them is that you should always provide your submitted proposal using the template. There are several cases that we are receiving proposals in the candidate's template that is not eligible, of course, and cannot be accepted. Of course, the submission, it will be through the ICT Flame website and this specific page that we have for the third Flame OpenCall. There is one form there, but you just select the type of your interest between the industry, SMEs, and startups in order to do your submission properly. And about the cities that you're going to select, as presented so far, we have 4 cities in Barcelona, Bristol, London, and this area in Sicily. Now for the SMEs, trials, you have to select in each one of them. So, but since we have 5 in total to be funded, so the 5th one, it will be, we will have, of course, 1 for each one of the cities, and the 5th one, it will be based on the ranking. So either in Bristol, Barcelona, Sicily, or London. For the startup trials, it is again the same. I mean, we will have at least 1 in Bristol, Barcelona, London, and Sicily, and the 2 additional ones, it will be based on ranking. And the industry trials, since we have only 2, it will be totally based on ranking in each one of these 4 cities. As mentioned at the beginning from Michael, and stressed as well from Sebastian, what is very important and different, let's say, from in this third OpenCall, if you compare the process with the previous ones, the first and the second OpenCall that we had in the project, now we are asking to describe how you will use these service design partners that we are offering in Flame project, and prove, let's say, and describe clearly, let's say, in your proposal how you are going to do this. So let's see a bit of the timeline. This is a timeline of the submissions, which means that, okay, the submission is open since the 8th of August, but up to the 10th of October, you have to submit your first draft in order for us to move on with the feasibility check that will last a week. And in the 18th of October, you will have the notification from our side about the feasibility check. This is not an evaluation, an official evaluation. I mean, we cannot cut, let's say, or reject any proposal in this check. We just provide as consortium a feedback to you on how you can do your proposal better, let's say towards the objectives of this open call and the features of the flame project. And then you will have some additional almost a month in order to prepare your final proposal and submit it up to the 8th of November. I'm sorry. Now, after that, we will move on with the evaluation of the received proposals, and you will have notification of the final results up to during the beginning of December, the first week, I guess. And the third-party projects will start early of January, between 1st and the 10th of January. Every project will last 6 months, so it will not be, any project cannot be ended after the 30th of June 2020. Now some information about the feasibility check. So this is a compulsory step in for the third open call, but as I mentioned before, this is not an evaluation step. So during the feasibility check, the partners that are responsible to do so from our consortium will review at least the sections A, B, C, and J. That is mentioned also in the information document, and will provide you a draft with some comments of how you can improve and what else it should be included, let's say, there in order to have a better proposal for this third open call. There are specific partners that are assigned in the consortium in order to do this feasibility check, including mainly the partners that are present here also in the webinar that are responsible for the infrastructure and also for the replicators and the technical solution of the flame project, and of course the coordination team. There are specific mailing lists that you can use if you want more information about the feedback that you are getting from the feasibility check while you are preparing your final proposal. So please use them in order to get any information that you need to, if there is something, any doubt about the comments that you have. And just please have in your mind that this is not an evaluation. This is just to help you to prepare a better proposal for the final submission. And in the final proposal, based on the feedback that you got from the feasibility check, you need to include another section that is part of the template as well. This is section E, and there you have to describe clearly how you meet the comments, each one of the comments that you received from the feasibility check. And this is important because this is also used as an evaluation criteria for the final ranking of the proposals. So these are the evaluation criteria. What is different from the previous open calls is that we have this additional one, the third criteria, that is about the use of the service design partners, and it has a maximum weight. As you can see, it's very important for us to see how you are going to use them. The rest of the criteria remain as they were. Just make sure that you are providing the information that you need in order to be evaluated high in each one of them. So that's all from my side about the process. I think, Michael, we can go back to you and maybe move on with the questions. Thank you.
Thank you, Lamprini. Okay, so we've just presented a lot of information. Thank you very much for listening. Now we have some time to ask any specific questions that you might have. So open the floor up, and it's over to you. So there seems to be something coming in the chat message about startups. Yeah, I can't really read it. It's very small.
The question is if the startups that are not legally established can participate. I'm not sure what do you mean by legally established, that the company is not yet schemed, or I don't know, that you don't have a legal identity. you always have time, if you allow me, Michael, to reply on that. All the documentation, let's say, about the startups, it will be asked from the winning ones only before the project is to start. So I think that if you want to submit your draft proposal now, I mean, based on the deadlines that we have, and then you are going anyway to create a legally well-established startup company, you have some time to do it, but you have to do it, you have to be ready before the project starts.
I think we, on the particular question about startups not legally established, I think we need to, I don't have a ready answer for that right now. So we will take that question offline and provide that as part of our FAQs. That's okay. Have we got Marcelino? If you could put in your email address, we will get back to you as soon as possible in relation to that question. Is that fair, Lamprini?
Yes, of course, of course.
In terms of the particular proposition on IPFS, again, that would need to be proposed and evaluated, and we can certainly answer questions. Does anyone on the call know what IPFS is?
It's a protocol to distribute content.
Okay.
So just to give a brief answer to that, I mean, we have not. I mean, we do have. We used to have one service that was using a CDN for Firebase, and then everything else was deployed locally inside the city to run the service. So the chain was essentially a mix between a typical cloud and a local deployment. Now, if the stack can be decomposed, and that was what the second slide deck was trying to trigger, that the decomposition of a service is what we really want to see, because otherwise you cannot utilize any of the service patterns. Therefore, the scoring on how much you use the service patterns will be really low, because if everything is just in the CDN and then everything else runs on the client itself on an app, there's not much you actually do in terms of the utilizing the patterns. So if you can make your stack so that there's certainly something you can deploy in the city, in the clusters, then we have no issues that there's partially something used or seeded in the CDN, but also bear in mind that I think IPFS is not using HTTP as the underlying protocol, and therefore you will not have all the benefits you can have with the platform.
Thank you, Sebastian. Okay, any further questions?
But Michael, there is another question about the test that can be made in Barcelona. If they can do the test in a very specific street, which is Pierre 4, Pere 4, I don't know, and to bring people to test certain app in the street where the flame lampposts are settled.
Hello, this is Carolina from I2CAT. So I'll read the reply to the question. I don't know if it's clear, but basically, yes, you can. I mean, experimenters can do that in the final experiment round. And also we, as Barcelona team, we can get to the street and get some devices if needed. We also have the emulated user equipment if the experimenters want to test with that. Yes.
Thank you, Carolina.
There's also a question further up before, Alicia, from Ismo, about how can we get answers from you. Last time we did not get any. The email addresses Lamprini was listing in her slide deck. If you send an email to one of the email addresses there, which was about the replication sites, you definitely will get an answer. So If there was no answer the last time, I mean, I have not seen any email from you, so I don't know where it went.
Yeah, I do. All I can do is apologize if we didn't answer last time. So yeah, please contact the email address in the slides provided by Lamprini, and we'll make sure that it happens this time.
Yeah, and the same addresses are included also in the 4 documents, so they are already available to you. So thank you.
Yep. Any further questions?
Hello.
Hi.
Yeah. Hi, it's Arsen from IS Wireless Poland. I do have some questions. These are rather technical questions. So I would like to ask you regarding QE models. Do you have some kind of QE measurement implementation already in your platforms? I mean, have you already implemented some ITU models like P1203 or any other video streaming models for QE measurements?
No, we don't have we have not implemented the models within the environment. No. Although.
Okay.
Although the QE measurements have not been implemented in the environment, although the ability to capture the metrics underpinning them would be possible.
Okay, good. Another thing is about adaptive bitrate algorithms. So I heard that it's you have some video streaming implementation already. So I was wondering if what kind of adaptive bitrate algorithm you have already implemented there. So I mean, I shouldn't add it in the part of proposal.
So for MPEG-, the algorithm is chosen by the playout point, which is the client, over which we have no control. So what we can do though is we can steer the client towards the rates it could possibly use by changing the dash MPD and just providing, basically saying, look, you have the choice between 1 Mbit, 10 Mbit, and 20 Mbit, and then it's up to the client to determine this.
Yeah, I'm asking about the client-side algorithm. So
we're not touching the client at all.
Okay.
So if you propose in your proposal, if you have a client implementation of MPEG- that chooses different or has a different way of calculating which rate it should use, we would highly welcome such proposal, because we have seen a very poor judgment on clients to choose the rates, because they are looking into latency in TCP, for example, which is the worst thing you can possibly do.
Yeah. I mean, for sure, for quality of experience for us, it's important to analyze these adaptive bitrate algorithm at the client side, because in actual settings, the quality is really poor as perceived in emulated or simulated setups. Okay, good to know that. Another thing is regarding UE automation. So I'm thinking whether is it possible to start simultaneously multiple UE requests in any kind of platform available right now in Flame or not?
What do you mean by starting multiple? I mean,
Okay,
can you describe
for
this a bit more?
example, I have 10 users, and I would like all these 10 to start video streaming uh, simultaneously. I mean, I want to understand the study of adaptation algorithms, how the client side adopts when multiple users are streaming all together.
So if you don't have a large number of users in the trial, so that you get your parallel requests or simultaneous requests, we do have emulated clients in each deployment of the city, or you just connect one machine where you start playing out the video 10 times. Because for the platform, there's no difference if you have 10 physical devices or same device with 10 requests shooting out, because we are just looking at TCP streams, right? And yes, you will see, once you do this type of experiment, you will see a response, and especially for 10 or for all clients that are asking at the same time, you will see that we're sending the response only once until the access point.
Okay, good to know. Another question, this is my last question.
Now you broke up.
Yeah, we lost that last question. We've lost you entirely. We can see that you're talking, Dr. Arslan, but we can't hear you.
Hello?
Hi, yes, we can hear you now.
Oh yeah, sorry, I don't know what happened. So the thing is, I have this question to guys from Barcelona, whether they have LWA and LWIP implementation already in their platform. It's something like using multi-rat environment and enabling these all together, Wi-Fi and LTE, or Wi-Fi or 5G new radio all together.
It is always from Barcelona. Yeah, so in Barcelona we only have Wi-Fi, so there is no LTE.
Okay, and in any other testbed, you have this capability, maybe from Bristol, LWA or LWIP enabling?
Bobby, do you want to answer, or do you want me to answer?
In the ones where 4G is enabled and also 5G NR is under deployment, so potentially we could provide you, but as to timescales, we have to confirm. So so are you anticipating the test? I don't know, for 3-4 months from now, or when is the possible testing time? Can someone confirm it?
I just want to add the functions that you're referring is not part of Flame project. Michael, do you want to confirm why we are asking for LTE or 5G NR access here? That's not part of Flame project, is it?
No. Well, the access network, no, that's certainly not part of the Flame project. Where was that referred to? For we've often had references to the 5G testbed in Bristol, including that aspect, but we know that it's not, because it's not part of the Millennium Square deployment.
Excuse me, I lost my connection in the middle, so I didn't know what did you answer. So
This is Hamid Falaki from Bristol. I want to know what's the reasoning for your question. Your question is to use either 5G NR or using LTE.
okay, yeah, sorry, I didn't give the background about it. The thing is, we have this multi-rat use case here in our company that we would like to use LTE and Wi-Fi all together. And in case of high traffic load on LTE link, we may want to offload some of the traffic to Wi-Fi link using LWA or LWIP implementation. So what happened in that thing is that traffic is tunneled using at the PDCP layer. So I mean, if LWA or LWIP is enabled in the testbed, we may be able to test our SDN app on that platform. So this was, I mean, my question was regarding that use case. So
We do, just on the LTE, we do have the function for the use of Wi-Fi and LTE combined, but this is a proprietary solution from our RAN vendor. It's not something that you could tamper with. It's the logic is there, full stop. It comes from the major vendor that works with us.
Hamid, the question here is whether the client can select the access network.
Yeah. So the answer to that is yes, it is possible, but you need to have your own.
Hold on. And this relates to the infrastructure supply slice offered to the platform. And I would like Sebastian to provide
okay. That's exactly, Michael. My question was to ask IDT. Yeah.
So at the moment, and also until the rest of the project, the Flame platform across all sites only has Wi-Fi as the access technology, mainly because any 4G/5G deployment would not allow us to deploy something at the very edge of the network. That is the main reason why we are not offering, or why we not try to integrate the solution of Bristol, for example, into the Flame platform, because we simply do not get access to the eNodeB, for example. So no, there's only Wi-Fi available, and you cannot select any other technology.
Thank you. Okay, any further questions? So I think that concludes our call today. Thank you very much for your questions and listening to what we had to offer. We look forward to receiving your proposal. If in the meantime anything else comes to mind, please don't hesitate to contact us and we'll endeavour to get back to you as soon as possible. Remember the feasibility study, that's mandated, and that's an opportunity for you to get feedback on not only the feasibility, but also on the feasibility of the proposal in relation to the capabilities we offer. I think that brings the call to the end. Thank you for your time and everyone who presented this morning, and have a great week.
Thank you.
Goodbye.
Bye.
Thank you.
Bye-bye.
Bye.
Bye-bye.